universe without the weak force can permit life, wouldn't that significantly diminish fine-tuning? No, it wouldn't. Oh, you want some explanation? Okay, let's talk about it. So I have seen a number of online videos railing against fine-tuning, and they frequently cite what is a very interesting paper by Harnack and some other physicists in which they plausibly show that you probably can have a universe still permit life even without the weak force. So this is an interesting find, and it's a great work by the team of physicists, but I don't think it does much at all to diminish the fine-tuning, since if you look at the article carefully, it says, for example, that they achieve this only by judicious parameter adjustment. And Luke Barnes has a great discussion of this in his review paper, where he summarizes some of the various compensating fine-tune requirements that are necessary in order to have a life-permitting universe without the weak force. So, for example, he mentions 4 parameters that have to be set by hand to about 1 part in 10 to the 20th power. These are Yukawa coupling constants. He also mentions that you would need about 100 times less dark matter than in our universe, which pushes it near a limit that Max Tegmark of MIT computed for galaxy formation. So it'd be very difficult to produce galaxies in the abundance that we have them in our universe without the weak force, because of the constraint related to dark matter, which tends to help galaxy formation, although we recently discovered at least one galaxy seems to have formed without much dark matter, which is quite interesting. But still, obviously, more galaxies are formed with it than without it, and it helps. So that's just something working against you a bit in that kind of weakless universe. Also, there's a baryon to photon ratio that needs to be very precisely set to about 4 parts in a trillion, basically. So that's a very finely tuned parameter that you have to add in to this weakless universe. The Carnot article itself says that there is no comparable way to compensate for the fine-tuning of the cosmological constant. So it's interesting that within the article itself, they explicitly argue for the limited applicability of this type of approach. So they're not necessarily trying to say, hey, we could do this with a lot of other finely tuned parameters and boom, they just magically go away. Some skeptics might be latching on to the fact that, oh, well, they're adjusting other parameters to compensate. And there is a bit of a myth going around on the internet, and it's a complete myth, that fine-tuning tends to go away if you vary more than 1 parameter at a time. But actually, physicists from the beginning analyzed fine-tuning by examining multiple parameters at a time and looking at coincidences across the parameters, ratios of the parameters, different things like that. And it was those coincidences that first caught their attention. So the myth, though, I think it may have originated from some popular level presentations or books such as Martin Rees. He's the Astronomer Royal, or was for many years, of the UK. Wrote a great book, which I highly recommend, called Just 6 Numbers. And within that book, he talks about 6 finely tuned parameters. And within each chapter, he's really kind of focusing on bounds just for that 1 parameter. But if you go and look at Martin Rees's published works, he's got a lot of published works where he's dealing with many constants at a time, analyzing how you can vary them simultaneously, looking for life-permitting regions. Very thorough, expert work by a top-notch astronomer and physicist, theoretical physicist. But consider this example from his literature, which Luke Barnes pointed out. It's a bit of a complicated equation. As you can see, there are many finely tuned parameters there, but it might be a little intimidating for the average lay audience. It might cause an allergic reaction for some with math phobia. Keep in mind that the fine-tuning claim is that life-permitting physics is rare among possibilities, not that there couldn't be other regions in parameter space where life could exist. I think a good analogy for the fine-tuning for life is to think in terms of there seems to be this vast ocean in parameter space of life-prohibiting physics where there's just no possibility for life, and you have perhaps a few islands where life could exist if you have certain combinations of parameters. So it's this multi-dimensional parameter space. Might be a little difficult to envision all the different dimensions, 1 per parameter, but even just think of it as a 2 or 3 dimensional space, and you can kind of get the idea that you can still draw a conclusion that we have finely tuned physics if if you just have a few islands within this vast set of oceans that prohibit life, only a few islands permit life, then yeah, it's still fine-tuned. So Harnik, to his credit, and his team, they seem to have found another island disconnected from ours where life could exist in parameter space. But because you have to have this judicious parameter adjustment and all these other fine-tunings which we don't need in our universe added in, that it seems to be a much smaller island than our universe because it's got additional finely tuned constraints. And so it doesn't do much to change that overall ratio of the parameter space which permits life to that which prohibits it. That you still have this vast disconnect between those. And so it does very little to adjust the overall case for fine-tuning.